Okay, here's our lab for today. The materials that you will need are a smooth surface, which is your table, a horseshoe magnet, a bar magnet, a ring magnet, a ruler, a paper clip, the lab station instructions, which are in this video, and the lab sheet. All of these items should be in your lab basket. Let's talk about force. What is force? Force is a push or pull that causes an object to move, stop, or change direction. Today, we will be testing a type of force. Looking at the materials in your basket, what type of force do you think we will be testing today? Predict what type of force you think. If you said gravity, you are correct. We will use these materials in front of you to test gravity. So tell me about gravity. What do you know about it? Gravity is the force that causes objects with mass to attract to one another. So now it's time to write your hypothesis. Write a hypothesis for this experiment. A hypothesis is a prediction. What do you think is going to happen in this experiment? Just look at the materials that we have and you know that we're testing gravity. So hypothesize what's going to happen in this experiment. Here's your sentence stem. I predict that. Write in a complete sentence on your paper where it says hypothesis. Once you have written your hypothesis, let's get started. The first thing you need to do is place your ruler on the table. Next, pick up the horseshoe-shaped magnet and place the magnet at 0 centimeters. Next, place the paper clip with its front edge at 10 centimeters. If your ruler is like mine and only has inches, you need to place it at 2.54 inches. That's the same as 10 centimeters. Next, move the paper clip closer to the magnet 1 centimeter at a time while holding the magnet in place. Remove your hand from the paper clip after each move. This will allow the paper clip to interact with the magnet freely. Hold the magnet in place throughout the experiment. Observe and record the distance at which the paper clip freely moves toward the magnet and attaches to it. What did you observe? Now, repeat the same steps with the horseshoe magnet 2 more times. That's a total of 3 times you are testing the magnet, this magnet, with the paper clip. So why is it important to conduct the same experiment more than once? 3 times? Why? Why do you think it's important for us to do a repeated investigation? Why is it important to conduct the same experiment many times? It's important to conduct the same investigation many times because this validates our results. What does validate mean? Validate means to confirm. We're confirming our findings. We are ensuring our results are accurate. Next, complete the same investigation using the bar magnet and record your observations. This should also be done 3 times and recorded on your paper. Did you notice anything different between the experiment with the horseshoe magnet and the experiment with the bar magnet? Now complete the same investigation using the ring magnet and record your observations. Did you notice anything different between the 3 experiments? Last, record your conclusion from your investigation on your paper. What did you learn? What did you observe? Reflect on your hypothesis. Use complete sentences in this section. Now let's discuss. What forces were shown during our investigation? Gravity and magnetism. Did you know that magnetism is a type of force? Consider what similarities magnetism and gravity have in common. What differences do they have? Does it make sense to you when you hear that both of these are forces? What variables stayed the same during our investigation? Our materials stayed the same, right? Their physical properties didn't change. The paperclip was a paperclip the entire time. Our starting point, where we placed the magnet, stayed the same too, right? What changed? The type of magnet we used. After 3 trials, we changed the type of magnet we are using. With that said, why is it so important to have only one variable in an experiment? Consider what an experiment would look like if we had several things changing throughout the investigation. It's important to have only one variable during an experiment because we want our data to be consistent. If we changed the size of the paperclip when we changed the type of magnet we used, how do we know what changed the data that we collected? Was it the different paperclip or the different magnet? We wouldn't know. We could make a prediction as to which had the effect on the outcome. However, we would not have a definite and conclusive data. What can you conclude about this force in this investigation?